All right. Alright, so for this example, I'm going to show you how do we calculate gradient. All right. So like in this case, if you notice all the gradient values, they have some numbers to it. So where does all these numbers come from? All right, it basically comes from a calculation. All right, it basically comes from a calculation. It comes from a formula. Okay, so what's that formula over here? So it's very simple. All right, so to calculate gradient, all we need is a straight line, okay, like this one over here. And this is how we calculate gradient. So gradient, I'll write over here, is defined as the rise over run. Okay, that's how I define gradient. It's the rise over run. Now, what do I mean by that? Okay, I will explain in a while, but just understand this first, okay? Now, to calculate gradient, there are one more information you need, which is the coordinates. And the number of coordinates you need to calculate the gradient, it's only 2. All right. So from this blue line over here, all you need to do is to choose 2 coordinates. It doesn't matter how near are the points or how far are the points. You will still get the same answer. I will show that when I do a working example for you later. But for now, let's just pick these 2 points. This one and this one. All right, let's just to understand how the formula works first. Okay. Now let's just say this is my first coordinate. So I will name this coordinate x1, y1. All right. So that's my comma over here. All right, x1, y1. This is my second coordinate. I'm gonna name this guy x2, y2. Okay, that is my second coordinate. So do remember how we find our gradient is rise over run, and where do we get that from? We will get from the triangle that is underneath the blue line. So let me draw that out for you. So if I will draw this out, do you notice that I can get a triangle over here? Right? So in other words, this part over here, that's the rise. All right, it is basically how tall is the graph. And over this part over here, that's the run. Okay? Okay? So let's work this out again. So basically, in another word, all I am looking for is the height of the triangle divided by the length of the triangle. But it's usually defined as the rise over run. The rise over the run. Okay? Now, how do we find the rise over here? What is the expression that I can write to represent the rise? Okay? Now, what are we interested in? The rise over here is going upwards. Okay? It's like rising up. So going upwards vertically, it is representing the y-axis over here. So if I were to plot the points over here, all right, this one. Okay, now for example's sake, this point over here, if you can imagine, this is going to be x2, comma, y1. All right. Okay, this point is x2, y1. Huh? So let's see over here. So we plot. So we know that this zone, this part of the rise, this is y1. And this part of the rise is going to be y2. So all I'm interested in is to find the distance between these two. Okay? So what is the expression I can write? Right, to find the distance between these 2 points. It's going to be y2 minus y1. If I take this, subtract with this, I will get this distance over here, right? So that is what I'm going to write. To find my rise, okay, I basically have to take y2 minus y1. That's my expression. So very similarly, how do I find my run? So again, if this point is x1, if you plot it down here, this point is going to be x1. All right, x2 is over here. All right, we can see x2 is over here. It's from the same point. So which means over here, that's x2. Correct? So if I want to find this distance over here, all I have to do to find is to have x2 minus x1, right? That's how I find the distance of my rise and run. So I'm gonna plug this in over here right now. So this is also equal. How do I find my rise? It's gonna be this expression, all right? So it's gonna be y2 minus y1, and everything, it's going to be x2 minus x1. And this over here, all right, is our formula to calculate the gradient of a straight line. Always remember that this formula is only applicable for a straight line graph, for a linear graph only. Okay, I'm going to put a note here because it's so important. For linear graph only. Okay, so remember that. All right, so that is how we work out the formula for the gradient. It's basically y2 minus y1 over x2 minus x1. Okay, so what I'm going to do now is we're going to do some work examples over here so you understand how we are going to use this formula. Okay. Okay, so for this, to show you how to use this formula, let's apply to these two questions over here. All right, so let's see what we're dealing with. So for each graph, all right, they give us a graph, they ask us to work out the y-intercept, the gradient, and the equation. All right, so the y-intercept, that's going to be simple. All right, so we can see it cuts through 3 over here, so we know the y-intercept is 3. All right, that's simple. But today we are interested in talking about the gradient. Okay, so again, gradient, what should we do? Remember these tips over here? All we need is to find two coordinates, and it can be any two coordinates from the straight line. It does not matter where the 2 points are from as long as it's from the straight line. So over here, I'm just going to choose 2 points. I'm going to choose the two easiest points for me to deal with, which is the y-intercept and the x-intercept. Right? Because those 2 points are the easiest point to deal with. All right, so have a habit, write down what's the coordinate. So in this case, this should be -6, 0. All right, because that's my x-intercept. And for my y-intercept, it's going to be 0, 3. Okay? All right. And then the next thing you will do is to choose which one is your x1, y1, x2, y2. Now for example's sake, let me put this as x1, and then this is y1, okay? And this one over here is x2, y2, okay? So for example's sake first, all right? Later I want to show you something. Okay, for now, I think this is good enough. Let's work out the gradient of this line. So to work out the gradient, remember it's going to be the rise over run, which is that formula we have proved earlier. So we're going to use that right now. So for my gradient, it's going to be the rise, which is y2 minus y1. y2 minus y1, in this case, is going to be 3 minus 0, all right? It's going to be 3 minus 0. Okay, I'm done with that. So next one is my x2, x1. So x2, remember it's this one. It's 0 minus -6. So how do I write this? It's going to be 0 minus -6. That's how you write it down. Okay? So all you need to do is to work this out and find the answer. So I will get 3 equals 0 minus minus will give me plus. It's going to be 3 over 6, which I can simplify this to 1 over 2. Or you can also write the answer as 0.5, whichever you prefer. Okay, so that's my gradient of the line. It's 1 over 2 or 0.5, and that's how we calculate gradient. Simple. But I want to show you something interesting here. Okay, now let's just say for some of you choose this one to become your x1, y1 instead. And this one, it becomes your x2, y2. Will it affect the answer? Let's try it out, all right? So I'm going to use the blue pen for this so you can see the difference. So let's see, will this give you the same answer or different answer? Let's try to work it out. So y2 minus y1, 0 minus 3, all right? So for my gradient, it's going to be 0 minus 3. And over here, it's going to be negative 6 minus 0. x2 minus x1, negative 6 minus 0. What do I get from here? I will get negative 3 over negative 6. Then both negative will cancel out, which will still give me 1 over 2 or 0.5. Can you see here? So what does this tell you? When you choose your two coordinate, it doesn't matter which one is x1, y1, x2, y2. You just pick one. Like for example, you found this guy first. Just call this guy x1, y1. Done. And this guy will be x2, y2. That's all. Don't confuse like, oh, will this be x1, y1 or this one x1, y1? It does not matter. Just pick one of the coordinate and call it x1, y1 first. And the next coordinate you found, call it x2, y2. All right? Simple. Because both of them will give you the same answer. So don't stress that out. Okay? Alright, same thing. Now the next thing, alright, just to prove to you my point earlier where you can choose any 2 points, alright, and it will still give you the same answer. So I'm going to choose 2 different coordinates from this. Now I know it's kind of difficult from this line, but let me get the coordinate out first. Huh? Let me see here. Okay. So let me just erase this. So let me get 2 different coordinates to show you I will get the same answer. So I will choose this point. This point is, last I checked from my screen, it's 4 and 5. And I'll choose another point over here. Let me check. Let's see. Okay. I'll choose this point over here. Alright. And this coordinate over here, it's negative 4 and 1. Right, let me just double check. Okay, good, that's good enough. Alright, you can clearly see I chose another 2 random points from the graph. And can I use these 2 points to find my gradient again? Let's try. Okay, so I'm just going to do it alright, over here. Alright, just going to erase this. Alright, just to show you this part. Alright, so again, to find my gradient, it's going to be y2 minus y1. So just now I found this coordinate first, right? So I will call this x1, y1. This one I will call it x2, y2, alright? So let's work this out. So y2 minus y1. So what do I get? y2 minus y1, 1 minus 5. So it's going to be 1 minus 5. That's okay. x2 minus x1, negative 4. Alright? Negative 4. It will be negative 4 minus 4. Okay? Negative 4 minus 4. So what do I get over here? So if you work this out, 1 minus 5, alright, that should give you negative 4. Negative 4 minus 4, that should give you negative 8, right? Negative will cancel out. 4 divided by 8, you can still simplify it to 1 over 2. See? Same answer. So what did I prove over here is basically, no matter which 2 points you choose from the straight line, how far, how short, it will still give you the same gradient. Alright, so don't stress out about that. Okay? So that's it. Alright? Okay, so this one I've proved to you. Alright? So since we already know our gradient, let's continue to work our equation out. Alright, let's continue to work our equation out over here. Alright, so we have done with the gradient. Let's work our equation. Now it's a straight line, so I know our equation will always be in the form of y is equals to mx plus c, right? So all you need to put in to make your equation is your gradient and y-intercept, and then you are done. So y is y, the gradient is 1 over 2 x, and the y-intercept we have found earlier, it's 3. And that's it. That's the equation of this straight line. Okay? Now, let's work out one more question, and I believe you will be able to get the idea. So first thing, to find my equation, I want to find my gradient. So two easy points I want to choose is my x and y intercept, all right? Because they have zeros over there, it's much more easier to deal with. So this one, my x-intercept, the coordinate is 6, 0, all right? For my y-intercept, the coordinate is 0, 3, okay? So again, I found this first, so let's call this x1, y1, and this one I will call it x2, y2, all right? And all I will do is to apply my formula. I will do it at the bottom here. So to find my gradient, all right, to find my gradient, so that's going to be y1 minus, y2 minus y1 is the rise first, it's always the rise. y2 minus y1. So in this case, it's 3 minus 0. And then everything will be divided by x2 minus x1. x2 minus x1, 0 minus 6. 0 minus 6. Okay, and then what do I get from here? I will get 3 over negative 6. And when I simplify this, I will still get negative 1 over 2. And it makes sense, right? Because the slope is going down, I should have a negative gradient. See? Negative is over there. Alright? And then we know the y-intercept is 3 over here, and we can make our equation. Our equation is always in the form of y equals to mx plus c. Alright, so all you need to do is to input the value of m and c. So your m is here, negative 1 over 2, x, and your y-intercept is written over here, plus 3. Done. That's how we calculate gradient, and that's how we write the equation of a straight line. That's all. Thank you.